So, hello everybody. Thanks for joining us. Welcome to the AnalyticsCreator event virtual classroom. We call it 60 minutes to create from SAP source a data warehouse on Microsoft Azure SQL DB. I will give you an introduction, just about 10 minutes, I hope. And after that, Dimitri starts with his live presentation. So first of all, I explain now AnalyticsCreator in a nutshell. What is AnalyticsCreator? AnalyticsCreator is a data warehouse automation technology which is made for experts, and it's also possible that juniors or not experts can work with AnalyticsCreator. It's working in that way that you have a holistic data model which you design, and the outcome is a source code instead of programming manually. So AnalyticsCreator orchestrates the life cycle of a data warehouse, of data marts and data lakes. It covers the design process, the development process, the change, and the deployment. You can use AnalyticsCreator to replace old-fashioned ETL technologies, but not only this, also to have more agility in your whole deployment process and development process. And it's up to 10 times faster and less costs. So now I give you three customer stories from the last years. This is the customer Robert Bosch. That story is now, I think, 2 or 3 years old. We decided together with Robert Bosch to redo a data warehouse, which was already developed, because we find out that it's much more faster to redo it instead of extend the development and adapt the things. So it was estimated 1 year development time. This was the time the people used before, and we have it done with AnalyticsCreator in around 2 months. Yeah, this is a really fancy, nice thing. And now this is one of the biggest data warehouse projects where Power BI is running. I think there are around 5,000 users at Robert Bosch every day. The next one is My Muesli. This is a small, medium-sized company, around 1,000 people. I think many of you know this company in the food sector. My Muesli had, it's now 4 years ago, they had no data warehouse in place, just some cubes, and they decided to grow up a data warehouse for more and better analytics, for advanced analytics and those things. And they had also no people there, so they employed a junior directly from the university, and of course you have to do a lot of training and theoretical things, and they just needed from us 4 days consulting to train the new people there, and they had done really everything by themselves. We just helped them 4 days for to grow up the first data warehouse in the sales and marketing area, and everything else they have done by themselves. So AnalyticsCreator can also be used for training purposes. So if you are new in the data warehouse and analytics stack, you can learn a lot of AnalyticsCreator because you see always from the design purposes always the outcome in the source code. So the next one is a huge real estate company. They had many instances of SAP in place, and they decided not to go with SAP BW. They grew up a data warehouse in the Azure cloud, and really, they were 20 times faster. At first, we could not imagine this, but this is what they reported to us. So we tried to sandbox the same, and we made a YouTube video you can see this in the YouTube video that we approved that it's really possible to do something 20 times faster. Yeah, it's amazing. So the next is the Data Management Survey 2023. Here you can see 22, but now in some days ago, BARC launched the 23, and we have now 4 years in a row, I would say, the best ratings all over, and we are still in place #1. And the right upper edge, also SAP is there. Yes, we can see, but nobody knows why SAP is there. They have no automation technology. We focus 100% on the Microsoft stack. We do nothing else. So this is why we think we are one of the best in this area. We concentrate on this, and when Microsoft come out with some new features and new databases, you will have always the possibility that we are able to generate on the new Microsoft stack. Yeah, so I think that's it from my side. I will stop now. I give the token to Dimitri, and he can show you now AnalyticsCreator.
Okay, then let me continue. Okay, one moment, please. I will present my screen. Okay, I hope you can see my screen. Peter, can you confirm, please?
Yeah.
Yeah. Okay. Good. Very good. Okay, then let me start AnalyticsCreator, and today we have a special demo. I will try to create SAP data warehouse from scratch and publish some parts of this data warehouse first on premise and then in Azure Cloud. Okay, then let's do it. Okay, first I started AnalyticsCreator, and now I will create the new data warehouse project. Let's call it demo SAP, for example. Now the repository database containing the data warehouse definition is creating. This data warehouse is located on my SQL server. It contains a full definition of my data warehouse, and you have full access to this database. It's very good structured, and you can use this database directly for your reports, for example, or you can manage information instances, data warehouse in this database. Okay, our empty data warehouse project is created, and now we will create the SAP data warehouse. We have two possibilities here. First, we can add the connection to the existing SAP system. If I click here on Add Connector, you can see here the different connector. Here are the different connector types which we support, and we support SAP2. We can directly connect to SAP system and read the metadata from your SAP systems. Or I will use another way how to create the data warehouse. I will use the meta connector. Meta connector, this is the definition of my data source stored in the cloud. It can be stored in the file too, but we have our own cloud, and here we have different connector definitions. For example, the definition of SAP-FI connector. SAP-FI connector. What is the meta connector? As I said, this is the definition of the tables and columns in the SAP system related to, for example, in our case, to SAP financial controlling. And here you can see all SAP tables related to this area. For example, the BKPF table. This is a booking header table, and we can take a look on this table, on the definition of this table. And important is I have no connection to existing SAP system, but I can create the data warehouse because I know the structures of the SAP tables related to SAP FI, and I can create the data warehouse. Later, I can connect my connector to the SAP system. It is very easy. I have to edit connector and enter here the connection string to the SAP system, and then I can compare my metadata stored in my connector with the metadata in the SAP system. Maybe you have some customer columns, set columns, for example, and your source definitions will be refreshed. And therefore, you can actualize your connector definition in case of differences between the connector definition and the source system. Okay, important is in this meta connector. Sure, you can create your own meta connectors, no problem. For example, you have to connect to the existing SAP system or any other system. You can read the metadata and store this metadata in the file or cloud, and later you can use the stored metadata, this meta connector, instead of the source system. You can work at home, for example, without to have access to the source system, and you can continue to work on the data warehouse. Okay, important is in our case this connector. In this connector, we defined here the references between the different SAP tables because the reference there is no reference metadata in the stored in the SAP system. And references are very important for data warehouse, and we maintained these references in our connector and stored the references together with connector. For example, this is a reference between booking header and booking positions. Let's take a look on it. We can see the tables backup AF and BSEC are referenced for using these 4 fields, and this information is stored in this meta connector too, and it will help us to create our data warehouse. Okay, now let me okay, what we can do first, of course, we can start to import the tables which we need to historize the tables and so on, step by step manually. Or, for example, I can say add import and then add historizing and so on. Or I can execute the data warehouse wizard. Let me do it. And wizard will create the draft version of the data warehouse for us. Okay, let me take some well-known tables from the SAP, booking headers, booking positions, customers, okay, NA1, vendors, okay, accounts, company concept, document types. Okay, and what I will do, I will import every table, I will historize every table, I will create dimensions using for every table, and I will create the fact transformation for my SEC booking position table. It is possible now to create the fact transformation or fact in our data warehouse using wizard, because the references between the tables are the part of our connector, and we can the wizard can create this fact transformation based on the existing references. Okay, what we can do additionally, we can define here the names of the objects in our data warehouse. For example, all dimensions will have dim prefix, fact transformation will have fact prefix in the front. Okay, next here we can add some additional properties. For example, we will create calendar dimension called team calendar for specific time period. But let's just click on finish, and wizard now is analyzing the metadata in our connector. In this case, it has no difference between meta connector and source system and existing source. If we would, it's equal if you use meta connector or the connection to the true SAP system. Wizard works by the same way. Is just analyzing the metadata in your source tables and trying to create for us the data warehouse. Okay, here you can see the typical data warehouse. Layer diagram. On the left side, you can see our sources. For example, this is a position source, SAP table. The next layer, this is a staging layer containing the data which we import. We import the data, for example, from the BKPF table into the imp.bkpf table in our staging layer. And okay, the structure of this import table is the same like the structure of the according SAP table. Okay, you can see there are some friendly names, some text information. For example, we have friendly names, descriptions for every SAP column. And import will be done using import package. This IP, this is the definition of the import package. Here we can see the definition of our import package. First there is a mapping between the columns in the source table and the target table. What we can additionally do, we can additionally add, for example, some filters, and I would add here, for example, the filter. I will import only the data for business year 2021 and more. Okay, yeah, so 2021. Sure, I can do it dynamically. I can, for example, use here the variable year and can define here this variable and can manage the variable content. But in our case, not necessary. We will only import the data for with a static where condition year is greater or equal 2021. I will just restrict the amount of data which we will to import. Okay, there is one, for example, here we will import the basic table, and I will add the same filter to the basic table. There's the gray year field 2, and we will restrict the amount of the imported data using this filter. Okay, very well. Okay, the next layer, this is a persistence. On all other tables, customers, vendors, accounts, company codes, and document types, we will import all the data from our data source, because the amount of the data is not too big as in the second BKPF tables. Okay, the next one layer is a persistent staging layer. You can see, let's take a look, for example, on this table, STG-KNA1. This is a historized customer table. And to historize the data, we use the slow changing dimension approach. This table, KNA1, has the same columns like the import table, plus 3 additional columns. 2 of them, this date from hist and date with hist columns. This is the date from and date to column. They define the validity period of our data row. Every time when the data will be historized, the existing data stored in the historized table will be compared with the data which we import. With the imported data, the differences will be detected, and the changed data, the previous versions of the changed data will be closed. So that this date will be set to the date of the historization, and the new row will be added. Therefore, in the historized table, we have the full history of the changes in our data, and we can every time access the previous versions of the data if we will. It is not necessary. I mean, it is okay. Can create data warehouse without to historize the data, but the data historization is very powerful and very important part of the data warehouse, and can provide you with additional information. Therefore, we usually recommend to historize the data. And one more field, this is this one, that's ID field. This is a surrogate key of in our table, because the business key of this SAP table of this table is not unique because we store the different versions of the data in the historized table. Therefore, we need the new primary key, and this column, that's ID of the type big integer. This is identity column. This is a new surrogate key or new primary key of this KNA1 table. The historization will be done using historization package. You can let's click on HP square, and we can see here the definition of the historization. We can configure the historization very widely. There is a lot of configuration possibilities. For every column, for example, we can decide the historization type of the specific column. If the full history of the specific field should be stored, or maybe if when the specific field is not unimportant for us, the history of the changes is unimportant for us, we can set the historization type to SCD1. In this case, only the actual values of this field will be stored in the historized table, but no history. None means the changes in this field will be not detected, and you can set it to none for absolutely unimportant columns. Okay, we can decide here what we should do. Since this missing source behavior, what we should do, for example, in case there is no data in the imported table, if we should close the existing historization record, or okay, it's really possible to configure the historization for you. For example, you can even use the existing historization, historized data. To you can take the existing historization data into your data warehouse. To do that, there is a column sources historized, and the existing historization can be taken from the source into your data warehouse. You can define here different filters, for example, to restrict the historizing data. You can create calculated columns to, for example, calculate the differences between the new and the old version of your data, and so on and so on. To perform the historization, we generate for every historization the stored procedures. Text of the stored procedures, class server stored procedure, you can see here. And if you want, you can even modify the stored procedure. If I set the stored procedure type to manually created, I can even modify it if I will, but usually not necessary. Okay, Then the next step, or the next layer, this is the core layer. In the core layer, we usually convert the relational, we usually create the facts and dimensions. This blue square, this is a transformation, usual transformation in AnalyticsCreator. This is the view. Let's take a look on this transformation. This is the regular transformation. Based on this tabular definition, AnalyticsCreator creates for us the view. This view text you can see here. Okay, there is nothing specific. Okay, there is only one table participating in this transformation. You can see here the columns. You can see here, for example, we instead to use the technical names like in the historizer table, we use the business names stored in the connector. It's not necessary, but in this case, the wizard did it. And we only expose every column from the, in our case, BKPF table in this transformation view. We support different kinds of transformations. The regular transformation, this is this transformation. Manual transformations, this is a manual view. You can create your own view and store it as manual transformation, and AnalyticsCreator will recognize all dependencies and will use this transformation as the regular transformation. There is a script transformation. Script transformation, this is a SQL script where you can, for example, execute storage procedures if you want. Okay, direct, no, direct is not important. External transformation, this is important too. You can create your own SSS packages, for example, or Azure pipelines, or even batch files or CMD files or Excel files, and you can execute such the transformation. You can implement such external packages or Excel files or batch files or CMD files as transformation in your data warehouse. But as I said, the usual transformation in AnalyticsCreator, this is a view. Okay. Let's take a look on this transformation, fact by sec. Let me set the filter. Set filter. If I set filter, I will see only the object depending on this object, or this object depends on. This fact by sec, this is our fact transformation created by wizard, combining different tables. You can see. Let's take a look on this transformation. The main transformation is by sec, and here we can see every table which have n-to-1 relationships to the BSEC table, BKPF, T001, and so on. And here, in the list of the tables, you can see, because we use historizer tables, you can see surrogate key. This is outside the column. This is a surrogate key from every historized type, historized table, which we use here in this this transformation. This is the typical approach, a typical Kimball approach. In the fact transformation, we only usually have the surrogate keys from the according tables, and maybe some measures, some which we will add now. But let us modify here something. For example, we have one. Let me remove filter. There is, for example, the table T003. This is a document type. This is not the part of this transformation or this fact transformation, because there is no reference between T003 and BSEC table. But add this day003 document types, but this day003 has a relationship with the table backup. Therefore, we can add here the references between the table number 7, this is day003, and table number 2. Okay, save. All the references we stored in the connector, and references now can be used, of course, in the data warehouses. Therefore, it's important to use references. And here we will add that ID column. This is the surrogate key from the doc types. We can call this column fk underscore the003. Okay, this statement allow us to use the unknown members for every dimension. This statement will convert, then in case, for example, there is no, I don't know, customer, this or other. Okay, for example, imagine in the basic table there will be used a customer, and this customer is missing on the table customers. In this case, we can use the unknown member. The customer ID will be set to 0, and 0, this is unknown member of the customer dimension. This is a typical data warehouse approach, and we use such unknown members here using this statement. This alias, this is just the alias which can be used to instead of this reference column. Okay, what we additionally will do, we'll add the calendar dimension. Calendar dimension is created by the DWH wizard. This is this one, team calendar. If I take a look on it, this is just the view, which provide us with the calendar dimension. And in the in my for example, in the backup table, table number 2. There is a column bookdatum or booking date, and I will use this bookdat column to provide calendar functionality into my data warehouse. But this bookdat column, this is the SAP date format, and we will convert it into ID from calendar dimension. And to do that, we can use macros. Macros is very important feature of AnalyticsCreator. Let me show you how it works. I will use here the macro SAP date to ID. Wait a moment, let me check exactly SAP date to ID. As I said, this is just the alias for the column used here in the reference column. Save, and I will call it fk dot. So, and let's take a look on the view created by AnalyticsCreator. And you can see instead of this macro, this SAP date to ID, we have here the statement. And let me show you how it works. Macro, you can see here, for example, some macros. You can define your own macros, of course. For example, we have here the macro date to ID edit macro. The date to ID macro, this macro, this is just the SQL statement. Or it can be, for example, DEX statement or MGX statement too. And in this statement, some parts are replaced by placeholders. This double.1, this is the placeholder. Later, if we call this macro, this placeholder will be replaced by the first macro parameter. If you use the double.2, for example, double.2 will be replaced by the second parameter. And this macro converts date or date time into ID from calendar dimension. Using this function dateDiff, we calculate the number of days between the date and the 1st of January of 1980. And so I said this macro just convert us the date into ID from calendar dimension. But we cannot use this macro directly with SAP data because SAP date, this is a string in format, for example, 2022, I don't know, 10/21. And here is another macro, subdate.id. In this macro, first we convert the SAP date into the date using this convert function, and then we call another macro, this date.id macro. That means you can call macros in AnalyticsCreator, and we use this functionality. And here we just used this SAP date.id macro to convert the Buddha column into ID from calendar dimension. Well, now let us add some measures or some important fields. For example, in the table BSEC, there is moment. So this is the field, and exactly quantity. Okay, then and tax. Okay, let's call it VAT. Well, we added some measures or some value columns to our fact transformation, and well, I think it's almost done. Okay, and now I created the model, and let me check my model. I click here on Synchronize DWH button, and this model will be materialized on my SQL server. This is my SQL server. The new database will be created. This database name is DWH underscore SAP demo SAP. Refresh. This is this one, DWH demo SAP. Demo SAP, this is the name of my repository. And if I click on Synchronize DWH, my model will be materialized here. And this database contains the structure of my data warehouse. And I can check it. It's okay. Anyway, every time when we click on Synchronize DWH, a new database will be generated, and okay, we can check if everything is okay. For example, if I do something wrong, let me do something wrong. For example, I will add here. I will produce an error here in this statement. For example, the view will looks like that. AnalyticsCreator cannot check if there is something wrong in this transformation or not. But when we click on Synchronize DWH, all errors will be detected. Let us check it exactly. Now you can see invalid column name in the transformation backup AF. The according transformation, the wrong transformation has a red border. Okay, the same error we would get if we click here on the create in DWH. invalid column name. Okay, let's fix this error, save. Let's synchronize our data warehouse again. And now I hope we have no more errors. Very good. Okay, let me do one more thing. This transformation fact-based is pretty complex, and to speed up access to this to the data in this transformation later in the data mart layer, I can materialize the data stored in this fact transformation. I can say add persisting. Okay, and now using persisting, the data from this view will be stored in the table fact_t. Okay, to do it, we have to we need a new persisting package, for example, pers1. Okay, let me synchronize data warehouse to refresh the diagram. Okay, and now you can see the content of this view will be stored in this fact_t table. This persisting will be done using persisting package or persisting procedure or persisting pipeline. Let's click on PP square, and here you can see how the persisting is working. We support different kind of persisting or materializing. Full means the content of the target table will be deleted, and every time the persisting table will be completely filled up with new data, the content will be deleted and the table will be filled up with the data from the view. We support different kind of incremental persisting, like merge. Historical means that the source of the persisting is historized and we can detect the new and old data, and so on. We support, as I said, different kind of persisting, and okay. But important for every persisting, the separate persisting procedure will be created, and if necessary, you can even modify this persisting procedure if you will. Okay. And the next layer in our data warehouse, this is a data mart layer. This is the interface layer of our data warehouse. Later, we can, for example, create the OLAP cubes, tabular multidimensional OLAP cubes, or Power BI models. And the OLAP cubes will contain the tables and transformations from the data mart layer. The objects in the data mart layer, this is just the views. For example, let me take a look on this one. This is just the view star.dim.bkpf, which exposes every column from the according core layer object. Okay. Interesting is, in our case, for example, this one, this fact_basic. This is nothing more than one more view, star fact_basic, which access all data from the according core layer. In our case, from this fact_basic T table. But let's take a look on this T square. This is a tabular definition of my view. We can see here all columns exposed by this view, and here we can add some additional information for our OLAP cubes, which we will generate using this data mart layer. Okay, here you can see, for example, the column bkpf is related. So you can see here this OLAP reference column is related to the table dim.bkpf. This is a reference between the fact and dimension. And here you can see every recording table is every surrogate key column or every key column is related to specific dimension in our OLAP cube. We will add some measures, and for example, let me take amount C, quantity T, you can see measure names looks okay, looks equal. Usually, of course, you can create your own. You can use your own measure names, but we can provide you with the possibility to automatically generate the measure names based on the templates. For tabular OLAP cubes, it's important that every measure name should be unique, and sometimes it's difficult if you work with very big model that all measure names remain unique. Therefore, for example, you can use in AnalyticsCreator such templates like aggregation name, for example, both column name and table name. And here in the column parsed measure name, you can see how your measure will be called. For example, you can see here this is a sum of quantity and so on. Okay, and well, let's add some additional columns. For example, we will add distinct count of vendors and distinct count of customers. Okay. I think we are almost done. Okay, ICC doc segments, very good. Let me rename do some renamings. You can call this friendly name. This is the name of the specific objects. How it will be called? Okay, not here. Here I don't need to change it. I can change it here. This is the name of this fact transformation in our OLAP cube. Fact, okay. Bookings. Fact bookings. Okay. Here I think we have to rename it to fact bookings. Let me synchronize my data warehouse to be sure that everything is okay. Okay, and I hope our data model is ready, and now we can deploy it. And to deploy, because the model itself, it is not the data warehouse. To create the data warehouse, we have to create the deployment package. And deployment package, let me create the new deployment package. Deployment, just the name. Okay, which components can, what is the deployment package? Deployment package, this is a Visual Studio solution containing some files, some objects. First, we generate the DECPAC file. DECPAC file, this is the definition of the relational database of our data warehouse. Most modern way how to deploy the SQL Server databases, this is this DECPAC file. And we can deploy this DECPAC file using AnalyticsCreator. You can deploy DECPAC files using according to Microsoft utility SQL package.exe, or you can deploy it directly from AnalyticsCreator. Okay, first I will create the on-premise solution on my SQL Server demo let's call the database demo SAP, why not? Okay, and here we decided to deploy the backpack. Then we will create integration service packages, and we will create tabular OLAP cube. Let me deploy my tabular OLAP cube directly in Power BI. We have the Power BI Premium subscription, and we can use the XML endpoint of the Power BI Premium to store the tabular OLAP models. And well, let's do it. Let's call the database SAP. Okay, login and my password. Okay, again, what I will do, I will create the local SQL Server database on my demo SQL Server, and I will generate the tabular OLAP model stored in Microsoft Power BI Premium. And I will generate integration service packages to fill up my SQL Server database with the data from the SAP system. Okay, okay. Important is if we use Power BI model, we should set the compatibility level to Power BI, and we will create the cube during deployment. I think that's correct. Okay. Okay, we can set the compatibility level of our packages and of our database to 2019. Save and deploy. Okay, now I clicked on deploy, and AnalyticsCreator will create the deployment package. And additionally, AnalyticsCreator will deploy my solution. As I said, it is not necessary to deploy directly from AnalyticsCreator. Maybe it has sense if you deploy into the test or development environment, but for productive environment, it's of course better to deploy separately. Okay, our database was generated. Now the OLAP cube will be created. OLAP cube is created in our Power BI, and now the integration service packages will be created. Okay, and let's wait a little bit. How our Power BI model located in cloud will get the data from our SQL Server database located on this is on-premise database located on our own server. We use the Microsoft integration runtime or this on-premise data gateway, and this data gateway provide our tabular OLAP cube, or our Power BI model with the data stored in our on-premise SQL Server database in this case. Okay. Packages will be generated. Let's wait a little bit. Okay. Okay, meanwhile, I can show you our database we already connected. Refresh. During deployment, we created the new database demo SAP. This is this one, because we deployed our DWH file, and this demo SAP, this is our data warehouse now. Later, when we deploy into this database, the existing database will be not dropped, or I mean, all changes will be deployed very intelligent. That means only the changes when we deploy the DWH files, only the changes in the database structures will be deployed. Therefore, we can use this demo SAP database as the data warehouse. And later, if we continue, if we will repeat our deployment, only the changes will be deployed into this database. Okay, the deployment package is created, and let's take a look on this deployment package. I am starting my Visual Studio, and let me open the project. You can see every time when we create a new deployment package, the separate directory is created. Okay, sorry, the temp is the temp here. The temp, this is the deployment package generated right now. And here you can see this deployment package, or this is a Visual Studio solution or SQL Server Data Tools solution. Here you can see first integration service packages created by AnalyticsCreator. And let's take a look, for example, on the import package, where we import the data from the SAP system. To import the data from SAP system, we use datawarehouse connector. Datawarehouse, oh, sorry, okay, clean. I should do one important modification. We created this package, but okay, you can see for every SAP table there is one separate container, but important is this source, SAP source, is not connected to any SAP system. And now, if we will really import the data from the SAP system, we have to connect this source connector to the existing SAP system. We can do it using the specific table called SSS configuration, located in our database data warehouse. Okay, but let's take a look on the workflow or control flow on our data warehouse. Our input package. You can see this is the datawarehouse component to get to load the data from the SAP table, and here okay, we calculate the number of rows, we perform some type conversions maybe, and then we insert the data into our import table, first using bulk insert. In case of error, we use row by row insertion, and all errors will be stored on the separate error table. Nothing specific, just the usual as integration service package. Here the import table will be truncated, there are some logging tasks and so on. And as you can see, we import the data from every SAP table parallel. Therefore, import can be performed very, very fast. Okay, that's how the import works. Then let me show you historizing package. Historizing package performs data historizations, and it's very, very easy package. Okay, come on. Some only the storage procedure, the historizing storage procedure will be executed in this historizing package, nothing more. And persisting package. Okay. In this persisting package, only persisting storage procedure will be executed. It's very easy. And one more very important package. This is workflow package. Workflow package will be usually generated by AnalyticsCreator, and this package will be used to execute every package in the correct order. You can see here first will be import package will be executed, history package, and then persisting package will be executed. And later it is you can execute this workflow package somewhere in, for example, SQL Server agent, and your build process will be executed. Okay, unfortunately, we have no connection to the SAP system now, and I cannot execute the packages, but would I have the connection to the SAP system, I can perform, I can execute the ETL process and load the data from the SAP into my data warehouse. Let's take a look on the Power BI solution which we generated. So, one moment. I will execute my Google Chrome, my browser, and this is my Power BI portal. In this Power BI portal, I have the workspace called AV, and in this workspace, I have this SAP connector generated by AnalyticsCreator right now, and here in this connector, contains the model. Would I have, I mean, later, for example, if I load the data into my data warehouse, I can refresh this connector, and then I can create the reports. Here you can see all the objects from my model. This is the fact bookings, my measures which we defined. You can see here accounts, all dimension, customer, and so on. As I said, unfortunately, right now, we have no access to the SAP system. We cannot fill up this model. Maybe in the next demo, we will be able to import the data from the SAP system. Right now, unfortunately, it's not possible, but you can believe me, it is very easy now to connect your created data warehouse to the existing SAP system and to execute your ETL process, and later you can create the models in the reports in your Power BI premium Power BI premium reports. Of course, but it's possible instead to store the data in the local SQL server, I can store the data in the cloud. For example, I have here SQL server, the Azure SQL server, and instead to publish my data warehouse on premise, I can publish my data warehouse on the Azure, because the DEC files which we generate are universal. You can publish them, such DEC files, both on premise and on Azure, and I can publish my DEC file on on Azure too, no problem. Let me show you how it works. Connect. For example, we have here, this is our Azure SQL Server. Azure SQL Server, we have here on Azure SQL Server an empty database called AV. I will not create a new database. I will use existing database where I will publish my my project. and will let me publish my SAP model to my Azure database. No problem. I now in my deployment package, I will only create the DWH file and only deploy this DWH file on Azure. I will not generate the integration service packages, and I will not generate the new tabular or the Power BI model. I will only generate the SQL Server database on Azure. Okay, let me do it. Save and deploy. As I said, using the same model created in AnalyticsCreator can be published everywhere. You can publish it on-premise, or on-premise. You can publish it in the cloud. You can publish parts of the model on-premise, parts of the model on the cloud. For example, now we will generate AnalyticsCreator, the database on Azure. We can generate. We already generated tabular OLAP model, Power BI premium model, but integration service packages, for example, we can execute on premise, and our Azure database will be filled up with the data from our SAP system, and later our Power BI model will be filled up with the data. Okay, now unfortunately our SQL Server instance is pretty slow. Okay, let me check, and it takes time until this deployment is performed. Therefore, we have to wait a little bit. But I think some objects are already created. Refresh. You can see the deployment is in progress, and this Azure database will be generated. But as I said, it will take a little bit more time because our Azure instance is pretty slow, our Azure SQL Server instance. Okay, I think now you saw how easy it is to create the SAP data warehouse using AnalyticsCreator. If you have questions, I can answer you. Peter, maybe you can continue, because I think I'm finished with my presentation, because it will take some time until SQL Server database is deployed.
Okay. So you want to that I speak a little bit about AnalyticsCreator. Okay, how long it takes? 5 minutes around?
I don't know. You.
Okay. So I want to introduce maybe our next virtual class. It's not the only virtual class. It's our AnalyticsCreator Congress. I mentioned already at the beginning. It's at the 10th and the 11th of November, in 3 weeks. This is an annual congress, and yeah, it takes 2 days, and some speakers are from partners, and some speakers are from customers. They tell you about our product and some success in the customer side. One interesting thing is the customer Kulmbacher Bier Brauerei. They will show how they achieved to move with existing data warehouse to AnalyticsCreator. So we have done there some reverse engineering stuff. that existing data warehouses can be moved very quickly to AnalyticsCreator. It's not fully automated, but it's something like automated. We have written some individual program there that store procedures can be transmitted from the old data warehouse to AnalyticsCreator. And
minutes, long, okay, almost 5 minutes, because as I said, our Azure SQL Server is less powerful than our on-premise. And here you can see this is the database generated by AnalyticsCreator. Contains all objects from the model, import tables, historizing tables, views and transformations, and so on. And would it be possible to import the data from SAP? We can. I would now execute the integration service packages. Integration service packages which we generate can be deployed to the Azure Datafactory 2, the Azure Datafactory compatible, or can be executed on-premise, of course. For example, many of our customers use Cloud SQL Server and Power BI Premium, but continue to use integration service packages on-premise to load the data from on-premise SAP into the cloud, which is most common architecture now. Or some customers continue to use SQL Server databases on-premise, and they use Power BI Premium to store the tabular OLAP models. Okay, well, maybe but I can show you more. Maybe I can show you the true SAP data warehouse from one of the customers. Let me check if I have here something. Okay, something like that. Okay, here you can see the true SAP data warehouse created in AnalyticsCreator. We can see on the left side a lot of SAP tables, and here on the right side we can see a lot of different data stars. For example, okay, let me take something. For example, order backlog. Set filter. If I set the filter, I can see only the objects related to specific data star. This is the order backlog, and we can here see a lot of SAP tables. Data will be imported, historicized, transformed, and so on. And you can see AnalyticsCreator is not only a data warehouse generator, but it is a data lineage tool. For example, if I will know where the data from the table ZBE Kun will be used, I can set the filter. I can see how the data from the specific SAP table, where they will be used, or remove filter. This is just one of the data warehouses from one of our customers, and here you can take a feeling what is productive AnalyticsCreator project and how it looks like. Okay, Peter, I think we can finish our demo.
Great.
If you have questions,
thank you, Dimitri.
Please ask me, and I will try to answer you.
So please ask Dimitri if you have some questions about what's the case in your environment. Oh yes, Richard has a question. Just speak, unmute. Yeah, right.
You can hear me? Hi.
Yeah.
Yes, we can hear you.
Hi. Thank you for the presentation. I was impressed, especially by the last part, where you had the tables induced deployed in your databases. The example you showed was about connecting to an SAP system and then modeling the data into a SQL server or Azure SQL database. What other data sources can you connect to with the AnalyticsCreator?
Okay, what other data sources? Okay, let's take a look on the list of the data sources which we support. Okay, at connector, for example. And okay, first, every database having ODBC or LDB driver can be connected using AnalyticsCreator. Text and CSV files, of course, Excel, SAP, every SAP version, SAP HANA, R3, and so on. Azure Blob Storage, you can read the data directly from Azure Blob Storage, from the CSV files, from the Parquet or Avro files. We support OData. And OData will be usually used to, for example, to get the data from SharePoint. Direct, this is a specific data source. For example, if your data source located on the same SQL server where the data warehouse is stored, instead to import the data, you can create the views, and a direct source will be used to avoid the unnecessary data import, and instead the views will be created. But important is, if we have no, for example, sometimes we cannot import the data into the data warehouse using AnalyticsCreator possibilities. In this case, we can create, or you can create, the externally filled table. This is we can create the container in the data warehouse called externally filled table, and you should input the data into this table by yourself. And for example, we have very good partners with data, and for example, we cannot directly import the data from Salesforce, for example, because we have no driver for Salesforce. But we can create the externally filled table, and you can use the specific tools provided by CData or by okay, you can develop your own, for example, program to load the data, and you should import the data into this externally filled table by yourself. And this is the second way how to import the data in case AnalyticsCreator has no own onboard possibilities to import the data. It's using the externally filled tables. Or another way, many of our customers, they have already some kind of staging database where they load the data from the different sources, and then you can use such storage database, such staging database to build your data warehouses. In this case, you can use the direct connectors to avoid the unnecessary data import. That is the third way how to work with the imported data.
Yeah, with our cooperation with CData, a US company, they have 250 connectors to many sources, and usually they push the data somewhere, and we pull the data somewhere out. So this is the easiest process.
And they can provide us with almost
different
the ODBC driver for almost every possible data source.
Yes,
we support ODBC, we support LDB, we support. Okay,
It means you can connect everything. Yeah.
Okay. Yeah. Well,
okay. Thank you. I'll took some notes. I'll get back to you with a couple more questions. I'm preparing for my 11 o'clock meeting now, so
okay.
Thank you very much.
Yes, thank you for your attention. And okay, it's 11, and we can.
Yeah, maybe there's another question from any from the audience. No more questions. Okay. Yeah, then I say thank you.
Thank you very much
joining us, and yeah, I hope we see you soon. And I also already mentioned maybe you have time to visit our AnalyticsCreator Congress in 3 weeks. The Congress is already live at Eventbrite, and I hope you will join. Thanks a lot.
Bye-bye.
Have a nice weekend.